So today's lesson again is on something brand new, something no one's ever taught you. So that's either exciting or scary or both, or I don't know what. But for me, learning something I haven't seen before eventually actually gets more exciting than the other way around. Today's lesson's on hyperbolas. Now, a hyperbola in mathematics is the locus of points such that the difference of the distances from any point on the hyperbola to two fixed points, and those fixed points are called foci again, uh, they remain a constant. So if you take any point on this, and this is what a hyperbola would look like, that would be two parabolas folding away from each other. And they could be sideways, or they could be, which is horizontal, or they could be vertical, where one's folding up and one's folding down. And we'll get into that as we graph it. These fixed points, again, are called foci. You take any point on the hyperbola, you measure the distance to both foci and subtract the bigger number from the smaller number, and that no matter where on the hyperbola you pick a point, that answer will always be the same. I'm going to make you recall that for an ellipse, you added, and the sum was always the same for an ellipse. For hyperbola, it's the difference. There are two types of hyperbolas. One is called horizontal. That's two parabolas folding away from each other. And the other is called vertical. That's two parabolas folding up and then the other one folding down away from each other. So the center, HK, is the midpoint of the foci. The vertices, which are the turning points, are plus or minus A units away from the center. The co-vertices, or the minor vertices, are plus and minus B units away from the center. What's called the transverse axis connects the vertices and has a length of 2A. So the transverse axis includes the vertices. The conjugate axis does not. And it has a length of 2B. It's going to be very similar to the work we did with ellipses. It's just that we're creating parabolas instead of oval, as it were. So if the points that we're getting, if we connected these points, we could make an ellipse. But today we're making an hyperbola, which is two parabolas folding away from each other. A hyperbola has asymptotes, and they are the diagonals that guide the curves. And the foci are plus or minus C units away from each other. Now I'm going to remind you that for an ellipse, it's the square root of A squared minus B squared. So you'd like to think that it's going to be similar. So to find C, it's the square root. In this case, it's A squared plus B squared. So for an ellipse, you subtract, and for a hyperbola, you add. All right, it's brand new, so we're going to be patient, and we're going to practice, and I think it's going to be okay. The standard form of a hyperbola, if it's horizontal, is x minus h squared over a squared. But instead of adding for a hyperbola, we are subtracting. And wherever the a is, that means it's the bigger number. So wherever the larger denominator is, it determines whether it's going up and down or left and right. So in this case, it's going left and right because the bigger denominator is underneath the x. Now, the transverse axis is going to be, in this case, y equals k. And the conjugate axis is x equals h. That's going to be flipped around. If it's horizontal, then, oh no, it's not, because it's y equals, I overthought it. So y equals k is a horizontal line that goes through the vertices. X equals h what we're going to do is create a rectangle, maybe in the middle, and through the diagonals of that rectangle, we're going to get what we need. And that rectangle that's created, the conjugate axis, is going to help us. The asymptotes, so the linear equation of the asymptotes, there's going to be two of them. So one's going to be a positive slope and the other is going to be a negative slope. And we take b divided by a to find the slope, rise over run, that creates a rectangle. And then we just take the center, and that becomes our hk of our linear equation. Here, for a vertical ellipse, the larger denominator is going to be underneath the y. In this case, the vertical, which is x equals h, that's going to be the main, the transverse that the vertices go through. The conjugate, that makes the other side of the rectangle in the middle, that our asymptotes are going to go through, that's y equals k. And then for this one, when we do rise over run, it's going to be a over b for these equations. And then x subtract h plus k. Notice again, just so you know, that the rise goes with the y and the run goes with the x. So that's why it's a over b. Here, rise over run, again, with the y and with the x, it gives us the slope. You're going to practice with me and have homework with me too another day. So we're going to practice together and we're going to get this. So turn the page. So first we're going to practice graphing. So let's just go step by step how we're going to do it. So first, to find the center of your hyperbola, look at the numerators. And there's nothing adding or subtracting there, so it's just 0, 0. So I'm going to put that right there at the origin. To find the vertices, you look at the larger denominator. So for the larger denominator, that would be what a equals. It's the square root of 25. So it's 5. So from here, and because it's under the y, we're going to count up and down. What did I do? Did I set this up wrong? I'm going to go back a page here. And we have y minus k. We have x subtract h. So I'm going to go backwards for you to make sure we don't make a mistake. When it's a hyperbola and you're subtracting, order matters. The size of the denominator does not matter like an ellipse. Instead, what matters is which one is positive and which one's negative, or which one is first and which one's second, no matter the size of the denominator. Different than an ellipse. So let's practice correctly from the beginning. I'm going to be on track here. So when I look here, the square root, we're going to start proper. So what's in front matters. So the square root of 4 is 2. That's a. And what's positive and what's in front is x. So that means from the center, I'm going to go 2 to the right. I'm going to go 2 to the left. And those are my vertices that my parabola is going to fold through. So it's going to fold to the right and fold to the left because x is first. So from the center, the x coordinate, we added 2 and we subtracted 2 to the x coordinate. Now, to find the b, which would be the conjugate axes, we take the square root of 25. So from the center, we're going to count up. 1, 2, 3, 4, 5. Going to count down. 1, 2, 3, 4, 5. And those are my co-vertices or minor vertices. That's going to help create a rectangle for my asymptotes. So to the y coordinate, I added and subtracted 5. So that's them. So I'm going to create a rectangle here, the size of my vertices. So can you draw a little rectangle here? That's the size of your vertices. Then through the diagonal. So you're going to go through the center, and then you're going to draw a broken line that goes through the corners. So we're going to draw a broken line, that's the asymptote, that goes through the center and through the corners of the rectangle. We're going to do the same thing in this direction. Now, when we draw this hyperbola, we're going to draw it from the vertex, and we're going to curve and let the asymptotes guide how wide it is. So see how wide this is? So we're going to start with the vertex, and we're going to curve sideways. One's going to go right, and one's going to go left. Maybe next time I'll use a red marker for the asymptotes. And kind of go from there. All right, so there it is. Your foci, we're going to take the square root, and we're going to add them. So 25 and 4, that's the square root of 29. And that's something like 5 and a bit. So not 6, like 5 and a half or close. So when I mark, I'm going to go to the right, 1, 2, 3, 4, 5, and a little bit. I'm going to go 1, 2, 3, 4, 5, and a little bit. And that's counting from the center. So from the center, count 5 and a little bit, and 5 and a little bit. That's your foci. Notice it's the x coordinate. So the x, and we went positive root 29, and we went negative root 29 to get the foci. Now the last part, the asymptotes. So there's two of them, and they're going to, one's a positive slope and one's a negative slope. And it's rise over run. So what's under the y is the rise. So it's 5 over 2, and then just use the center, which is at 0, 0. So I don't need to go plus or minus 0 and then plus or minus 0, but it would be hk where you would use those numbers. Now 0, 0 means there's nothing adding here or nothing adding there. So it's just plus or minus 5 over 2x. And that was your first hyperbola, right? A little bit scary at first, but we're going to keep practicing and get it right. Number 2, can you graph this hyperbola? So first of all, I noticed the y is positive in front. It's not the size of the denominator, but which one's positive. So this is going to be a vertical hyperbola. Now look at the numerator. The x and the y still gives me the center. There's nothing adding or subtracting, so it's 0, 0. Next, my a is the square root of 36. So from the center, I'm going to count up 6. I'm going to count down 6. My b is my minor axis, which is called the conjugate. That's the square root of 9, which is 3. So 3 to the right and 3 to the left. And then I'm going to draw my rectangle, that size. So from the center, draw this. Those are my asymptotes that go through the center and the corners of the rectangle. Remind myself what type of hyperbola this is again. It's vertical, so I take the vertex that's vertical. This is the one, the vertex that folds up. So I fold up the parabola following the asymptotes, and then down here, the bottom vertex, it folds down. We're going to write this information down now. So where were the vertices again? So I added and subtracted 6. So 0, 6, and 0, negative 6. The covertices, I added and subtracted 3. So 3, 0, and negative 3, 0. The foci, that is the square root, and you add the denominators. So that's the square root of 45. And the square root of 45 is somewhere between 6 and 7. So 6 and a little bit. That's what we're going to do. So from the center, go 6 and a little bit. And then here, count down 6 and a little bit. And then put an X down there for your foci. So this is to the Y coordinate. So to the Y coordinate, we added root 45 and we subtracted root 45. Now the asymptotes. So we know the asymptotes, there's two of them. One that has a positive slope and one that has a negative slope. I'm interested in the Y coordinate. So the Y value, what is that? So in this case, that's 6. So that's 6 over 3. Rise over run, 6 over 3. And then the HK. And because the HK is 0, 0, I don't need to put those numbers in, and you have it. You could also write this as plus or minus 2x if you wanted to simplify it. All right, number 3. First, what type of hyperbola is this? So which one is positive and in front? Doesn't matter the size of the denominator. It's x, so it's going to go sideways. So my a is the square root of 16. My b is the square root of 1. And my c, might as well do that right away, as I add them, so it's the square root of 17, which is a little bit more than 4. Now I'm going to put this down on my graph. So my center, my x-coordinate is positive 3, and my y-coordinate is negative 1. So find where 3 and negative 1 is, and start from there. Now from 3, negative 1, you're going to create a rectangle that your asymptotes are going to go through. Now the size of the rectangle, the x value is going to be 4 in one way and 4 the other way. And the other size of your rectangle is 1. So 1 up and 1 down. So it's a 2 by 8. So draw that rectangle. This is going to guide your asymptotes. So when I draw my asymptotes, I go from the center and go through the corners. From the center and go through the corners. The center, through the corner. The center, through the corner. Now, at this point, I need to remind myself, is this sideways or vertical? So it's horizontal. So that means I take the sideways vertices. So here's one that goes to the right. Here's one that goes to the left. And you're taking that vertex from the rectangle, the sideways one. And there you've graphed it. So to find the vertices, what was A again? It was 4. So you have to add 4, that's 7, or subtract 4, that's negative 1. And the y-coordinate stays the same. The co-vertices is 1, so the x stays the same. Add 1, that's 0. Subtract 1, that's negative 2. For the foci, it's the square root of 17, and it affects the x-coordinate of the center. So plus and minus root 17 and negative 1. So that's where the foci is. The asymptotes, rise over run. So it's positive slope and a negative slope. Now I'm looking at the y value. So this would be 1 over 4 because the b goes with the y. So 1 over 4. And then the center. So that would be x subtract 3 plus 1. That's the HK. And then plug it into your line. And it's done. All right, let's try it again. So I want you to see, is this going to be a vertical or horizontal hyperbola? And because the y is positive and in front, it's vertical, not the size of the denominator. So a is the square root of 4, b is the square root of 9, and c is the square root of 13, where you add the denominators. Our center, be careful here, because our x-coordinate goes with the x. So be careful when you look at it and you see the x-coordinate. So the x-coordinate is actually negative 2, and the y-coordinate is positive 4. So be careful to know where the x and the y are. So I'm going to start with negative 2 and 4. Now that I have my center at negative 2, 4, now I'm going to make my rectangle. So for this one, I'm going to go up 2 and down 2. So that's a size of 4. And I'm going to go to the right 3 and to the left 3. I'm going to make my asymptote. Start at the center, go through the corner. Center, go through the corner. Center, go through each corner. And extend through the corner so you have room for your parabola or your hyperbola. Next, remind yourself what type of hyperbola this is. It's Y. It's vertical. So it's going to fold up and it's going to fold down. Now write down what the vertices are. So for the vertices, we added and subtracted 2. So it's -2, 6, and -2, +2. For the co-vertices, that went with the x's. So we add and subtract 3. So add 3, that's 1, 4. Subtract 3, that's -5, 4. For the foci, that affects the y coordinate. Now we didn't even put the foci on here, so let's put the little foci on here. So for the foci, the square root of 13 is between 3 and 4, like 3.5. So I'm going to count 1, 2, 3, and a little bit. And I'm going to count here 1, 2, 3, and a little bit, which makes me wonder if I put the foci on the last one, which I don't think I did. I'll go back. So it affects the y coordinate, the foci here. So for the y coordinate, it would be -2, 4, plus and minus root 13. Now for the asymptotes. So it's y equals plus and minus for the equation of the asymptotes. Rise over run. So y goes with 2. So it's 2 over 3. And then the center. So it's +2 plus 4. And you have your equation of the asymptotes. Can I just go back, make sure the foci is on the other one? All right, back here, just make sure I put the foci. The foci is 4 and a little bit to the right and left. So from the center, 4 and a little bit. From the center left, 4 and a little bit. And you can put your little X's there to see where the foci would be. All right, last one to graph right now, number 5. Can you find the center is at 0 and -3. This is a horizontal. So A is the square root of 25, B is the square root of 36, and C is the square root of 61 because you're adding them together. So let's start here, 0, -3. Then from 0, -3, 5 to the right, 5 to the left, 6 up, 6 down, and then create your rectangle using those vertices. And now your asymptotes. So from the center through the corners. The center through the corner, center through the corner, center through the corner. Remind yourself what type of hyperbola this is. It is sideways. It is horizontal. So we're going to take the vertex right and left and then curve our parabolas using those vertices. So it curves left and it curves right. Now we're going to write down what those vertices were. So the ones we just curved through, we're going to add and subtract 5. That's 5, -3, and -5, -3. For the minor vertices, we use 6. So it's 0. When you add 6, that's 3. 0. When you subtract 6, that's -9. The foci, we use root 61. Now we haven't put those on my graph yet. So root 61, what is that close between? So 8 squared is 64. So it's getting closer to 64. So it's like 7.7, 7.8, 7 a little bit. So from the center, we're going to count 7. That's 5, 6, 7 a little bit. and then again to the left. So that's 5, 6, 7, a little bit. And then you have two little x's that determine where the foci are. So to the x coordinate, we added root 61 and we subtracted root 61 to the x coordinate. Now the asymptotes. So rise over run, plus or minus. Now, which one goes with the y? 6. So it's 6 over 5. And then the center. So it's just x, but then we need to subtract 3. Because of the h is 0, I don't need to put plus or minus 0 there. All right, so there's your practice on graphing hyperbolas. Something you've never, ever, ever done before, but fully a part of pre-calculus, and I'm glad that we're getting a chance to learn this. Now, can we do the work that we did with ellipses? And that work is, if the equation is not in standard form where I can graph it easily, could you change this to be able to put it in standard form? That means, can you complete the square? It's the same steps that we did in our last lessons on ellipses, but we're going to do it now with hyperbolas. Now, how do I know this is a hyperbola to begin with? Is that one squared or quadratic term is positive and the other one is negative, and they're on the same side of the equation. If they're on opposite sides, then they would both be positive, because when you bring them together, one would be positive and one would be negative. All right, step one is the x's. That'd be 9x squared and 90x. Then the y's, well, I only have a negative 16y squared, and then the constant can stay there on the right side. Next, I'm going to factor out the quadratic term if I need to before I complete the square. So I'm going to factor out the 9. That leaves me with 10, because 9 goes into 90, 10. And then I'm going to remind you what we did in the last lesson to complete the square. We took that number 10, and I'll do it right here. We divided by 2 and squared it. And we did it in our head. So 10 divided by 2 is 5, and then square, and that gives you 25. Now to the y, I don't need to do that because I have no linear term there, and then 351. Now we're going to factor. So this is x plus 5. Oh, I did one thing I didn't do. I'll go back. So factor it. What did I forget to do? There's a number, right, to add to the other side. Now, the number that wasn't there before is not 25, but is 9 times 25. That's 9 quarters. That's 225. Then when I add this up, that adds up to 576. That's what I'm going to divide by. If you need a calculator, it's okay. I'll do the calculator work for you. 9 goes into 576. If you divide it, it goes in 64. So x plus 5 squared over 64. Here, 16 goes into here evenly. Divide it, and you get 36. So it's y squared over 36 is equal to 1, and you're able to write this in standard form. The center of the hyperbola is at negative 5, 0. You can see that the square root of 64 will give you your vertices, your minor vertices, the square root of 36, and so on. But we're not graphing right now. We're doing the algebra to write it, so if we did need to graph it, we could, and find the important parts of the hyperbola. All right, let's try it again. Now, for this, we're going to make sure we put this in the correct order as well. The positive quadratic term needs to come first. So when I look at here, I see negative 4x squared, and I see negative y squared. So to put this together, I'm going to add y squared, which makes y squared positive, which means it's going to come first. And then there's a negative 6y beside it. The negative 4x squared, negative 56x, they go together, second. And then we have a 287, and it's going to be left on the right side. Both of these I need to complete the square. So for negative 6y, and I'm going to put parentheses around it, just to separate it from the x's. Divide by 2. Well, negative 6 divided by 2 is negative 3, and square it. That's 9. To the x's, I have to factor out first before I can complete the square. So I'm going to factor out a negative 4. Be careful when you factor out a negative, because when you factor that out, a negative and a negative is actually going to make this positive when you factor out a negative 4. And 4 goes into 56 14 times. Now, To complete the square for x, we're going to again divide by 2 and square. So 14 divided by 2, that's 7. Square it, that's 49. And then what number do I need to add to the right side that was there now on the left side that wasn't there before? So I need to add 9. And in this one, I need to actually be careful. It's actually negative 4 times 49. So because it's a negative, it's actually not adding on the right side, but subtracting. That's the number that wasn't there before. If I didn't have a calculator, I would go negative 4 times 50. That's negative 200. And then go back 4. So that's why it's 196. But I'll be your calculator. Then factor. So that's y subtract 3 squared, negative 4. This is x plus 7 squared. And then combine like terms. Again, I'll be your calculator. 287 plus 9, take away 196. Put that together, and it's actually 100. Divide by 100. Simplify it, and you have it in standard form. So our first fraction is y subtract 3 squared over 100. Then it's x plus 7 squared. Now 4 goes in 125 times, and then 100 divided by 100 is 1. Done. Turn the page. I knew this would happen if I used the red marker I had was going to bleed through on the other side, but it's going to be okay. Here, again, I want to write it in standard form. So which one is the positive quadratic term? 25x squared, and it belongs with negative 50x. Then we have a negative y squared, and it belongs with negative 10y, and that's equal to 100. Then I'm going to factor. So I'm going to factor out 25, and I get x squared minus 2x. Now, I'm going to divide by 2 and square it, so it's plus 1. Here, I'm going to factor out a negative 1, so that I have y squared plus 10y. It's important that it's positive 1 in front of the quadratic term. Oops, divide by 2 and square, that gives you 25. And then it's equal to 100. Now, what number should I have on the other side? So 25 times 1 is positive 25. Well, negative 1 times 25 is negative 25. So one is positive 25, and the other is negative 25. So obviously this is just going to be 100. So we have 25, factor it, that's x minus 1 squared. Here, we have a negative 1 if you like, but to factor it, that's going to be y plus 5 squared, and that's equal to 100. And then divide everything by 100 to make it equal to 1. So the end answer I'll put here on the right side. It will be x minus 1 squared over 4 minus y plus 5 squared over 100, and that's equal to 1. Two more. Well, again, we're not going to do the eccentricity at all for here. So that, we'll just put a big X here. But just 9 and 10 in the lesson stuff. Can we write this in standard form? So the x's. Notice I want the positive quadratic term first. So if I add 4y squared, there's the positive quadratic term. Then we have 64y. For the x's, we have negative 9x squared and positive 36x. And that's equal to 104. Next, we're going to factor out a 4. And that leaves me with y squared plus 4 goes into 64. 15? No. 16. 16y. Now, divide by 2. 8. Square it. 64. Factor out a negative 9. Be careful when you factor out a negative. That's going to change the sign of the linear term. So that's going to be negative 4x. Oops. Divide by 2. Negative 4 divided by 2 and square it. That's positive 4. Now, what numbers get added or subtracted to the right side. So 4 times 64, that's 256. I'll be your calculator. Negative 9 times 4 is negative 36. So now we have an equal equation that was before. We're going to factor this. So that's y plus 8 squared. We're going to factor this. That's x subtract 2 squared. And then on the right side, we're going to combine like terms here. So 104 plus 256, take away 36, is 324. We're going to divide everything by 324. And that's going to give us our answer. So I'm going to write our answer right here. So it's going to be y plus 8, 324 divided by 4, that's 81. Subtract 324 divided by 9, that's 36, and that's equal to 1. Last one for our lesson here. Can you write this hyperbola in standard form? So identify the positive and negative. Now in this case, we could write it, we have to make sure that we have it equal to positive 1. So the constant term really should be positive. If it is, should be left there on the right side. So in other words, in this case, 4y squared is going to be the positive quadratic. Then I'm going to add 24y. I'm going to subtract x squared, so it's the negative quadratic. And there's a plus 12x. And then we're left with positive 196. We want to also know that this constant is a positive number. So when we divide, we get positive 1. It can't be equal to negative 1. All right, we're going to factor. Factor out of 4. That's y squared and 6. Now divide by 2 and square it. That's 9. Same thing here. We have to factor out the negative 1. So factor out a negative 1 and you get x squared minus 12x. Divide by 2 and square. That's 36. And then what are the numbers? So 4 times 9, we need a 36. Negative 1 times that, that's a negative 36. So they're going to cross out. So what I'm left with here is y, and I'm going to factor it, plus 3 squared, negative 1. Here, x minus 6 squared. And then on the right side, if we cross out the 36's, they undo each other. That's 196. So we're going to divide by 196 to get our final answer. So 196 divided by 4, that's 49. We don't need the 1, so it's just subtract. X subtract 6 squared over 196, and that's equal to 1. And we were able to complete the square to write this in standard form. I know, it was a brand new lesson, and I'm proud of you that you worked your way all the way to the end of the lesson to do something you've never ever done before. To be able to graph a hyperbola, to be able to complete the square and algebraically be able to write it in standard form. So I'm proud of you. Mr. G Math over and out, and until next time, keep doing your work.